Hello, everyone. So I have a student, and the student asked me to record a lecture on IPQC in SMT. Okay, SMT meaning surface mount technology, then IPQC. I didn't know what IPQC is, so I actually Google what is IPQC. Not here. Let's see here. So I Google what is IPQC, and what it basically means is a quality engineer position. Okay, so in process quality control. That's what IPQC means. So what he was looking for is info on quality engineering position, or what a quality engineer would do. That's what he was looking for. And then he wants me to cover issues like inspection of SMD production, solar paste, component placement, reflow, AOI results, and all that stuff, and some of the certifications. So in this video, I'm going to cover all of this as best of my knowledge, okay? Because I'm really a PCB manufacturing person. I have been doing PCB assembly for the last 4 years, so I have enough knowledge to teach, but there are a lot of things that I'm still learning. Okay, so let me try my best to teach what a quality engineer does in SMT. Now, in this video, I'm only going to focus on SMT, which is surface mount technology, and I'm only going to focus on reflow technology. Now, what is reflow technology? Well, here's what SMT reflow line looks like. Okay, so this is a reflow oven. So something like this. Okay, something like this. This is a reflow oven. So I'm going to stick with a simple reflow technology, because whatever I teach in this video can easily be transferred over to hand assembly, soldering with soldering iron, or wave soldering, or vapor phase technology. It doesn't really matter what technology you're using. The overall concept of quality engineering will remain the same. So let me start this lecture, and we'll talk about quality engineering in this video. Okay, so first let's understand what a reflow line is. Okay, so let me show you a better picture. Here's a good picture. So in a reflow line, let's say you go to a PCB assembly house. We call them contract manufacturing, right? So a PCB assembly house is either PCBA facility or contract manufacturing facility. That's how you call them. Okay, so in a PCBA, in an assembly house, if you're looking at the reflow technology, this is how the lines will be set up. Okay, the lines will be basically a screen print. So the bare minimum line that we are talking about, the bare minimum would be a screen printer, a chip placement machine, we call them pick and place machine, and a reflow oven. Okay, so you will apply solar paste on your PCB, then you will place components on your PCB, and then the boards will go through the reflow oven, and the oven will heat up the solar paste. Solar paste will melt, and the components will stay at their location. And once the boards comes out from the other side, the temperature, the solar paste will go back to its normal temperature. That means it will solidify, and your components will be placed as you intended. So in the end, you will have a populated PCB. You will have a assembled PCB. That's the bare minimum. Okay, but then if you are a good quality assembly house, you probably want to add some extra stuff in there. Like, for example, you want to add a solar paste inspection capabilities. Now, you can inspect by your eyes as well, but you cannot measure. I mean, you can inspect solar paste, but you cannot measure the thickness of solar paste. And when you're doing a mass production, you can't have people just looking at solar paste all the time. You need automation. So that's where an SPI machine comes in. An SPI machine will do a lot of things, and we will look at it in a bit what SPI does. But SPI machine will enable you to measure the thickness of solar paste. And so you can have an SPI machine for a screen printer, because screen printer is printing solar paste, right? And then you have a pick and place machine. So when you have a pick and place machine, when you're placing components on your PCB, you also want to make sure they're placed correctly. So how do you make sure they're placed correctly? Well, you can look at them with your eyes, but with your eyes you can only catch so many problems. Okay, not everything. And nowadays, components are very, very small, and it's very hard to catch errors during assembly on those small components. Then you need automation. And when you do automation, that's where AOI machine comes in. AOI is automatic optical inspection. And you can program these machines to detect errors on your PCB. So when, after pick and place, when you run the boards through AOI, it will tell you exactly where the problem is. Now, what happens is, if you run it, through AOI at this point, okay, going back, if you run a solar SPI machine and it tells you that you have errors, well, you can take those boards back and you can wash those boards and reprint. So you don't waste the board. You just reprint. You wash off the solar paste, and then you redo the process again. You adjust some settings over here, and then you redo it until you find the right amount of solar paste you need. Once you're good with it, then you can move on to the next level. So this way, you're not really wasting a board. You're just cleaning it and reprinting it again. Same thing here, automatic inspection. So you have the solar paste, okay, the board comes to pick and place with the solar paste, and then you do an AOI after pick and place. If the components placed are not correct, you can go back, okay, you can go back and repopulate the boards, or you can actually do it by hand if there's an error of one or two components, or you can completely remove all the components and redo it. There are a lot of things you can do. Again, the idea here is that you don't waste a board. So if you had 100 boards and this was the first board you were playing with, you can still keep fixing it up and using it. Once the board goes through the oven, and once your solar paste is solidified, then the board is assembled. Then fixing it is still possible, but it becomes hard. And at that point in time, when you fix a board, it will be called rework, because you're reworking the board. See, at this stage, solar paste hasn't gone through the thermal cycling. So it's not considered, you are reworking the process, but the board itself are still not really reworked because they're not permanent yet. Once it goes through this, everything becomes permanent. And if you're fixing the board after this stage, then it's considered to be a rework. So you need to understand this part. And then there are other machines as well, but we will worry about them later. Now, so far we learned two things, that there's something called solar paste inspection and there's something called AOI inspection. So I'm gonna make my notes over here, okay, just so that you know. SPI stands for solder paste inspection. AOI stands for automatic. So these are the two concepts we learned so far, okay? Going back here. So these are the two things you do. Now, how do you apply solar paste over here? Okay, when you're applying solar paste, you basically, well, first of all, how does a solar paste printer looks like? Solar paste printer. Okay, they're different. This is manual, then you have automatic ones. Here's a good example. So basically, you put a PCB on your tray. Then you put a stencil on top. So this, what you're looking at, is a stencil, and then you fix the stencil. then you align the stencil. Well, you align the stencil with the PCB, and then you fix the stencil. How do you align it? You use tooling holes. Okay, you have tooling holes in boards, and you have tooling holes in your stencils. So you can use those tooling holes to put the pins to align them together. That's one way of doing it. You can also have fiducial, but tooling holes are designed for that. So you use tooling holes to, that's why tooling holes are very important on your array. So if you have PCBs in an array, you gotta have tooling holes. And those tooling holes have to be in your stencils as well so that you can align the stencil with your PCB. Okay, once all this is done, then you put your solar paste over here, just big, solar paste like a paste. You just dump it on there, and then these are called squeegees. So you set up specific pressure and speed. Speed of how fast it moves, and pressure on how much pressure is applying when it's moving. That speed and pressure will allow the solar paste to go through these openings, and this is the way you will deposit solar paste on your PCBs. Now, this is stencil. Where's this stencil coming from? Well, you're most probably subcontracting the stencil to some company to make you a stencil, okay? So where's the design coming from? Well, the design is coming from the designer. That's why designers, when they create the PCB design, they have solar paste file, top paste, bottom paste, depending on if it's double side, if it's assembly used on both sides or one side. Okay, and then PC manufacturing people, they will have to take the solar paste file and panelize it exactly like the PCBs they're panelizing. So if a PCB manufacturing company is giving 4-up array to a PCB assembly, they better have the solar paste files panelized with their PCB Gerber files, and they should supply that to the PCB assembly guys, and then PCB assembly guys will ask their supplier to make the stencil based on that. Here's what I mean by PCB array. So you see these PCB arrays, right? Let's take one. Okay, let's take this one, for example. So you have a PCB array, so solar paste file. So, PCB manufacturing company is doing this, panelizing it, and then they should also have the solar paste files panelized exactly same, and they should supply to a PCB assembly company so they can send those files to the stencil company to make the stencil. Now, those openings that you saw over here, these are SMT pads, right? SMD pads, so surface mount devices pads. So basically, all the pads where you want solar paste, because that's where you're going to mount the components, those pads have to be in this, in the Gerber file so that you can have them in stencil. So if you miss one pad, your stencil is going to be wrong. So that's why engineering has to make sure all the pads are there and the sizes of pads are correct as well. I don't want to go too much into how to determine correct size, because that's really going in the engineering side, outside the scope of this video, but you can figure all that out later. Anyways, so you have these tooling holes. That's why these tooling holes have to be there so that you can align your array with your stencil. Now, going back, so that we talked about that pressure, the squeegee pressure, and the time it takes to go through it. So that's very important. So we are going to, look at Stencil, and under Stencil, we are talking about pressure and speed for the squeegee. Okay. Also, other thing is, how thick is that stencil and what material is that stencil? In most cases, this is stainless steel, but sometimes it's other as well, something else, like it could be a steel stencil as well. But without going into too much detail, very important thing to consider is the thickness of stencil. Why? Because the thickness of a stencil will allow for depositing the solar paste. So let's say you have a 3 mil stencil, so it will allow you to deposit solder paste. Solder paste usually is a little bit more than the stencil, so if 3 mil stencil, you're probably depositing 4 mil, 4.5 mil. There's no specific rule, that's just general observation. So depending on your board, you need to determine how much solder paste you need. Now, I can't answer that because it all depends on, when you're doing your printing, you have to figure out if the quality is good or not. And that's, again, a totally different issue. But that's how solder paste stencils work. So you need to figure out what thickness of stencil you want as well. So going back, thickness. So these are the three variables that you need to take into account when you're dealing with stencils and a stencil on the solder paste printing machine. Okay. Now that's how solder paste printing machine works. Now, other thing is cleaning of stencil. So let's say your stencil company supply you the stencil, and then you saved it at your facility, and now you're ready to use it. Well, you have to make sure that the stencil is clean. So cleaning stencil is very important. Now, when it comes to cleaning stencil, there's a cleaning before you start using. So you need to make sure your stencil is clean. You need to clean your stencil. And then there is cleaning of a stencil after every use. Now, you don't always clean the stencil after every use. Depending on the stencil, you may want to clean every few use. So again, that is exactly what process engineering is. You need to figure out as a process engineer, after how many times of use do you want to clean the stencil. And the reason you're cleaning it, because over time, the solder paste starts to deposit at the corners of those SMD pads. They start to deposit, and when you keep using the stencil without cleaning, it starts to give you variation in the application of solder paste. So you will have a solder paste thickness problem. So that's why you want to make sure that you're cleaning your stencil after every few use, or maybe after every use. I don't know. It all depends on the job itself. So that's something you need to consider. So let's go back. Okay. Cleaning stencil prior to use, and then cleaning after use before next use. Okay. So we will keep these notes. These notes will help you understand and remind you what you need to do. So this is the job of the process engineer, okay, and the operator as well. So process engineers will figure out what should be the thickness, because there are IPC formulas that helps you determine the thickness of the stencil. So process engineers will need to figure out that thickness using those formulas. They will figure out what squeegee pressure and speed should be, what should be the cleaning cycles, and then the operators will have to follow these values that the process engineers come up with. Now, in most cases, the whole SMT line usually have one process engineer, but in a mass production facilities, you can have multiple process engineers on the same line. So you can have one process engineer only for solder paste, one for pick and place only, and one for reflow one. It could be. It all depends on the type of company you're working for, and the kind of products that they're making, and how much of the product they're making. So I will leave that alone, right? There's no reason to get into that. So this is how the solder paste printing works. Now we can see SMT pick and solder paste SPI machine. Let's do this. It's hard to see, but yeah, that's what it is. You put a board, okay? You put a board, like for example, this one. You put a board inside, and the cameras will actually take the measurement and tell you what is the thickness of solar paste. Okay, and some of the good machines, I believe some of the high-end machine can also look at a pad and tell you, at one corner, if what's the thickness at one corner versus what's the thickness of another corner on the same pad. I'm not 100% sure, but I think that's how it is. I've seen the machines like that. I believe so. Anyway, so that's the SMT. So now let's look at the SMT pick and place machine. So pick and place machine is a very complex piece of equipment. Okay, here, let's start with here. So you can see in a pick and place machine, you have these reels. Reels have components. So, let's say you have a capacitor you buy that capacitor in a reel and then you place those reels over here. So there are a whole bunch of things come into play here, okay? You want to inspect the reels, make sure that you're using the correct reel, meaning you're using the correct component. Then you want to place them in a specific sequence. And that sequence is determined by how your SMT program is, how the engineering made the SMT program. Now, what do I mean by SMT program? Well, for your machine to pick the component and place it on your PCB, you need to give the machine XY coordinates of each component and where it's going to be placed. Now, if your PCB is about this big, you have a whole bunch of, let's say you have 100 different components, right? You want to make sure that, well, there is an engineering behind which component goes first and which goes second and which goes third. The engineering is, well, one is path optimization. You want to make sure that if you place a component here, you're not going to place the second one here and then third one here and fourth one. What you want to do is you want to place 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So you go in this path where you're spending the least amount of time pick and placing, because that's how you optimize your program. That's how you optimize efficiency. If your machine is going all over the place, then it's taking more time for placement of the component. So that's the optimization comes in. But then there's something else to consider. Sometimes it may not be possible to place a whole bunch of components right beside each other. Some are big, some are small. So that's where engineering comes in. Engineering has to figure out how to place them. Some maybe needs to be placed by hand, some not. So there's a lot of things going on, when you're making the program for SMT, pick and place. Also, in these pick and place machines, you have nozzles. Nozzles have air pressure. Okay, they're like vacuum nozzles, and then they have the vacuum in the middle. That's how they pick up the component. They don't pick up the component like this. There's a nozzle, there's the air, and it just goes and touches the component, picks up with the air. Let's see if I can find SMT pick and place machine nozzle. Yeah, you can see. Yeah, you can see. Let's see if I can pick. It's hard to pick a. I think you can see it's not really sharp pointed. There's it's like a cylinder. So there's, so in the middle there's a air. Basically, it sucks the air out. So that's how it picks up the component using vacuum. Okay, suctioning mechanism. That's what it does. Here you can see it better. None of them is really. This is the area you're using. None of them is solid. They all have a hole in the middle. So yeah, so that's the thing. You need to also make sure what nozzles you're using, because the correct nozzle will allow you to pick up the components correctly. If the nozzle is too big or too small, it may end up damaging some of the component, or may not be able to pick them up. So if the component is too small and the nozzle is too big, it may end up sucking the whole, the component, probably not inside the nozzle, but shift incorrectly, and then it will place incorrectly. So the programming aspect, during the program, you have to figure out, first of all, the engineering has to figure out how to do the pick and place, what path. They have to figure out the path, and then the SMT engineers will need to figure out which nozzle to use for which component. Okay, so that's one thing. So let's write down. Okay. Correct. No, optimize path for pick and place. Correct nozzle size, right? So yeah, so these are the things you need to consider. Okay. So once you understand, okay, so I was talking about the reels, right? So you have to also consider. So here, there's a better example. So you see the gap between each one of them. These are the racks that holds the reels. So these racks, the distance between the rack is also important. Again, this comes under a SMC engineer responsibilities to figure out how much should be the distance between the rack, because that determines the picking speed and the picking placement of the component, something along that line. But so spacing between the racks with reels. Remember, as I said, I understand overall concept of PCB assembly, but I have never really worked in this field for long enough to know every single thing. So that's why sometimes I struggle to explain things. Okay, but that being said, this is good enough for now. So yeah, so that's how pick and place machine works. So pick and place will, the nozzles will pick these components from the reels and then place them on your PCB. So once they've done that, they go to the next level. No, not here. Okay, the next level is AOI machine. So SMT, let's see, AOI machine. Okay, so AOI machine, you will program the possible defects on that PCB in the machine, and the machine scans the PCB and actually tells you if it matches those defects. It will tell you that, hey, here's the defect. I will print you the report. Now, the question is, what are the defects? Well, that's an interesting one, because you need to understand what kind of defects are there during PCB assembly. So the next question is, how do you find out what are the defects? Well, the defects are defined in IPCA 610 book. You can see it's an expensive book. It's not cheap book. It's expensive. But this is where you will find the defects, what is acceptable, what is not acceptable. But this book is not just for SMT. It's for PCB assembly. That includes hand assembly, that includes through-hole assembly, that includes a whole bunch of things. But this is the book we refer to, and this is the book that tells you what are the defects. So you have to master this book to actually understand. There's no point of me recording lecture on the defect, because all that already exists. And if you're working for a professional company, they will have this book. So you need to read this book and understand this book. Now, nobody is dumb enough to memorize the book. That's not the idea. You should read through it and understand it and refer to the book when you need to. Now, the thing is, the question is, should you buy the most updated book or not? Because IPC updates specification often, like every year, every 2 years, and they release amendments. Well, as a professional company where I work, we always get the updated version. And it's needed because that's what customers refer to, right? But that being said, from learning point of view, if you have the older version from 10 years ago, it's good enough. You don't need to get the latest one for learning or for reference. Every year or every other year when they release amendments or release updated version, there's few differences. And as a company, you need to have those new updated versions. But again, just for learning and for reference, you can use an older version, and that's completely okay. So if you have an older version, I say stick with it for your, for understanding, for learning point of view. But other than that, if you're working in a professional company, you have to have the updated version because that's what customers will expect you to. So again, yeah, so you need to have this book and you should refer to this book to understand what are the defects. And then over here, there's another one, there's a requirement for solder electric and electronic assembly handbook. So this standard J standard, we call it J standard, is also very important. So yeah, you need to have the IPCA 610 book. You need to have J standard. So these are the books you need to have. They are expensive, but that's what it is. You need to have these books, and these are the books that will tell you everything. Now let's look at SMT defects. Oh, okay. So SMT defect, there could be many defects. You got solder bridging, tombstoning, right, inefficient solder, component misalignment, non-wetting, de-wetting solder balls, yada, yada, yada. And then how do you troubleshoot? It's just a standard, but these are very standard ones. Let's see if it shows me pictures. Yeah, if you Google SMT defects, it shows you a lot of pictures. Again, no point of me going over all of this. This is something you should be able to learn on your own. You just have to read some books and some of this stuff and to understand. Oh, this is a beautiful one. So it's actually it's not very high quality, but it tells you solder bridging. It has pretty much all the main. Oh, here you go. It has all the main problem already explained here. These are the major defects, but there is a lot more in those IPC 610 book. It covers a lot more. Like for example, it will. Well, this is basically saying, one of these like not making a contact. But if you read the IPC 610 book, it will also tell you. You see this right here, solder joint. What is the acceptable solder joint? That's what you're going to learn in the IPC 6A10. Is it too much? What happens if solder paste is going over here? What if it's under here? All these things are in the IPC 610 book, and that's why you need to have that book. So yeah, so just for the SMT defects, standard stuff is right here. Now the question is, how do you program these machines? Well, what you have to do is, let's say you're running a new part number XYZ123. You have to take one XYZ123 board, maybe more than one, and introduce these defects in that board. Okay, you have to make that board bad on purpose, and then program that bad board in the machine, so the machine will recognize those errors in that board, and it will memorize those errors. And then when you pass a good board, it will compare the bad board that it remembers, or the defects that you introduce. It will remember those defects and then compare them with the good boards and tell you if the good board is good or the board is bad. So yes, you would have to take one or two or three boards and introduce the defects, all these defects that we saw. Where do we go? These defects you would have to introduce on that board by yourself, and then use that bad board to program the machine so that it can do the comparison with the good board. That's how you use the AOI machine. Okay, going back. Okay, let's go back to SMT line. Did I say line? SMT line. Yeah, here you go, right? Okay. Yeah, so then there's a reflow oven. Reflow oven is a standard, pretty straightforward. It's an oven. It has multiple chambers. So what happens is when you send the board to the oven, it heats up so let's say melting point is 300 Celsius, for example. It's not, but let's say 300 Celsius. The oven doesn't go straight to from your regular room temperature to 300. No, it will destroy the board. It will destroy the component. So what it does, it has multiple chambers. Like I know we use Heller oven at my company, and it has 9 chambers. Now, do all the ovens have 9 chambers? I don't know. I'm actually not sure. Maybe some have more chambers. I don't know. But what it does, it gradually increase as the board passes through the different chambers. Each chamber goes higher and higher and higher and higher, and that's how you do. So lower temperature, the board will pass through the lower temperature for longer. So let's say it passes through 50 Celsius for maybe like 7 seconds or 8 seconds, and as the temperature increases, the time passing through those chambers decreases. So when you hit the melting point, let's say 300, it's not going to go through 300 for like 10 seconds. It may just go through 300 for like 2 seconds or 3 seconds. You're just quickly melting it, and then you're letting it solidify. So that's how this reflow oven works. So pretty straight. It's an oven, nothing more. You can bake your pizza in it. It doesn't matter. So maybe I should try making a pizza one day. But that being said, that's how the oven works, and yeah, that's what it is. Now, what are the things you need to consider when you're running an oven? Well, you have to come up with a thermal profile. You have to know what a thermal profile is. What is a thermal profile? Let's Google. What is a thermal profile for SMT? Yeah, this is really good. A thermal profile refers to a time temperature graph that illustrates how the temperature of a printed circuit board changes as it moves through a reflow or during the soldering process. Yes. So basically, as it moves, you're basically you're trying to tell the machine, how much time it needs to spend in each chamber and what should be the temperature of each chamber. Again, this is where SMT process engineers come in. It's their job to figure out. Excuse me. So how do they figure out? Well, there's a lot of engineering goes behind. So you have to use special equipment to actually do the thermal profiling. Now, here's the thing, what I want you to know. I go to smta.org. I am a member there, so I'm going to log in. Okay, I'm going to log in. The thing is, okay, it's pretty slow. You should become a member of SMTA, okay? Because SMTA is a non-profit organization. I have 2 accounts. I have personal account. When I was a student, I registered with SMTA, and I think I paid $20 lifetime or something like that. But if you are working for a company, your company should have a corporate membership as well. They most probably do. So I have a corporate through my company as well. I have that account as well. So I am logged in, okay, which is great. I'm going to go to technical knowledge here. Wow, it's very slow. It's probably my internet. So you have a lot of stuff here. But what I want to do is, why is it so slow? Okay, so basic assembly process courses. Let's go here. Nope, this is, yeah, here you go. Okay, it's just my internet, I don't know, it's just slow. Okay, so you will see a lot of courses here. And the thing is, once you are a member, all these courses are free. If you're not a member, you have to pay, I don't know how much you have to pay, like $100 or something per course, or $200. I think it's $200. But anyways, I became a member as a student a couple of years ago. I paid $20 or something like that, and I'm still a member. So for me, all these courses are free. So I suggest, if you want to increase your knowledge, you should sign up with SMTA, and all these courses will become free for you. So it tells you exactly how to clean your stencil. That's exactly what I was talking about. Component placement essential. That's what we were talking about. Reflow soldering essential. I think there's thermal profiling is part of it. And then there are more courses, as Stencil Printing 101, Component Placing 101, Reflow 101, Wave Soldering if you want to. I don't see too much wave soldering because wave soldering is really for through-hole components, and not for SMT. It's still done in Asia and it's still done here as well in North America, but not much. Selectric soldering, thermal profiling. Here you go. There's a course on thermal profiling. Okay, cleaning 101 and then rework 101. So there are a lot of, and then there's a 201 course which I have never taken, and I just saw it, so I think SMT just updated their website. It's a little bit new. I have never seen this new website before. So, anyways, yeah, there are a lot of courses, and I believe they're trying to release more courses as well. So you should be part of SMTA organization, and you can take a lot of courses. Good thing is I don't have to cover thermal profiling or a lot of these because it's all there. Anyways, so that being said, this is how an assembly process works, just the overall. Now, let's go look at what this thing is saying, what the student wanted. Wanted me to cover reflow, AOI results, solver paste component. Well, I have explained everything how these things work. How you use it, I cannot give the answer of, I cannot give more answer. I mean, this is something you have to do on your own and just do it, right? And then how to write report, well, you have to figure out, in most cases, Excel sheet. I would say start with standard Excel sheet and go from there. I talked about IPC A610 already and IPC 9001. ESD certification is straightforward. What is ESD? How do you protect yourself against ESD? You wear the wristbands or ankle bands. Your equipment has to be grounded. You should always be grounded. These are the things that cover ESD. Again, ESD certification is a standard. You can probably do it online. But for IPC certification, ISO 9001, again, ISO 9001 is a quality management system. It has not, I mean, every company has 9001. It's not really related to PCB. So again, 9001 is something you should read on your own. Nothing to do with my course. It's something you should do it on your own. IPC 610 is what related to this video. Yes, and as I said, you have to read the IPC 610 book on your own. That's the book. In that book is what explain. The book explains everything on what is right and what is not right. Okay. Okay. So I'm going to cover a little bit more of all of this now. Let's go here. So I actually Google quality engineer responsibility for SMT process. I came with, I'm using Google Gemini. So there's a lot of stuff, and a lot of stuff is just standard journal stuff. It's nothing to really cover. I will talk about a few things. All this stuff here is a standard. I mean, everybody does it. You need PFMEA, you need, control plans and all that stuff. But let's focus on this. I talked about SPI. I talked about AOI. X-ray, I forgot to talk about X-ray. So and manual visual inspection. Let's talk about these two things. What does X-ray does? Well, you should also have an X-ray. Usually the X-ray machine is not in line. What does it mean by not in line? Let me go here. SMT line. Let's go back to this again. Here, we were looking at this, right? Okay, we got the SPI, we got the AOI. Okay, interesting. In this one, AOI is after the reflow one. And that's okay. Sometimes it's before, sometimes it's after, sometimes it's before and after. It all depends on how you set up your line, and it doesn't matter. It depends on what kind of production you're doing. So, I leave it to that. And then it's not here. Usually, PCB X-ray. I wanted to see if I can find PCB X-ray in any of the lines. Okay, let's say SMT X-ray. What does X-ray does? X-ray can tell you things you cannot see with your eyes. So if you have a fully assembled board and you put it through an X-ray machine, it can show you what's going on inside your solder joint. So once you do an X-ray after you've assembled the board, and if you see for whatever reason if the board is failing, and if you do the X-ray, you can see maybe there's a void in the solder joint or whatever, something is not correct. So that's what X-ray does. You can see, these are all X-ray images. So you can see through multi-layers of PCBs using the X-ray. So that's what X-ray does. And usually X-ray machines are not in line. Oh my God, I'm keep doing this. So inline means all these machines are all in line. Usually X-ray units are on offline, meaning you can have a X-ray unit placed on the side somewhere, because not every single board is X-ray. You only X-ray a board when you really need to, just to do a quality check. Other than that, you don't really use an X-ray for every single thing. You don't need to. So that's what X-ray does, and that's why you have X-ray inspection and you do X-ray inspection. Then you have manual visual inspection. A lot of time you can get away just by using manual visual inspection, but manual visual inspection can only be done using a microscope, can only be done on a larger components, not necessarily on every single small component, but the components. But the thing is, visual inspection can catch a lot of things that SPI and OR machine cannot, like contamination, or like some other issues, cosmetic issues as well. So you still need manual visual inspection, but most of the errors you catch using SPI and AOI, but you still need manual and visual inspection. And the thing is, your visual inspectors should be IPC certified. Okay. Now, what does IPC certification means? Now, in Toronto, we have in Toronto, we have a company that does the training for PCB inspectors, and then they certify them. Let's say PCB inspector certification. So your inspectors need to be certified for IPC 610 and IPC 600. 600 is a PCB level, 610 is a PCBA assembly level. So there are different programs, there are different certifications for all of them, and your inspector should be certified to this. So that's important to consider. Okay. And then all of this is, that's just a standard stuff. So I'm going to close this. I don't need this. I'm going to leave this open. So yeah, we talked about a quality engineer. A quality engineer will most probably focus on SPI, AOI, X-ray, and all that stuff. But what I have noticed is maybe in a very large corporation where they have multiple lines, you have defined roles. But a lot of time, SMT engineers are also acting like IPQC. So you have IPQC, which is the same as an SMT engineer. But it again, depends on the structure of a company. You may have multiple people. You may have just one person doing the whole thing. It really doesn't matter. But that's what it is. Now let's look at some of the things that this person should do. Person should perform regular inspections and various points. Yeah. So we talked about various points. 4M 1E analysis, which is 4M is for machines, right? Man, machine, material, method, and environment. Okay, man. What does man refer to? Your operators. So your operator should be trained. You probably need to do a gauge R&R study once in a while to see if your operators actually know what they're doing, and or that if you have 5 operators, all 5 understand problems exactly same. That's why you need to do gauge R&R studies on your operators once in a while to see if they are all on the same page. And also you need to have them all trained, maybe yearly training on ESD, on ISO, on IPC, different IPC specs. That's what man comes in. Machine calibration, preventive maintenance, all those things comes under machine. So you should have a proper plan for preventive maintenance and calibration. That's part of the machine. Material. So the materials you are buying, let's say solar paste. What kind of solar paste you are using? Well, that is determined by the engineering. They will tell you if it's water soluble or if it's no clean or whatever. That's depending on the customer requirement. But as a SMT engineer, you get to choose, or you would have to choose which supplier you want to use, because different suppliers make solar paste differently, and some suppliers have very unique solar paste which tackle very unique problems. So you need to figure out materials, you need to figure out what solar paste you're using, you need to figure out who's going to make your stencils. Okay, solar paste is stencil. And then the stencil, as I said, different thicknesses, different materials, and then even on top of the material, different people, different companies make stencil with a different coatings, special coatings on top. Again, those things needs to be figured out, and you need to focus on all that as well. Method is all about process engineering. So you need to figure out how to do the process engineering and improve processes as you go along. That includes what pressure you're using and what time, what pressure and time you're using for a squeegee. That's part of process engineering. Optimization of your pick and place program. That is also method. Thermal profiling comes under method, and all these things are method. Environment. The student who I'm talking to, this lecture is for that specific student. He's from a place in India called Noida. I've never been to India. I don't know where it is, but I know Noida. If I'm not mistaken, it's a coastal city, or I could be wrong, but whatever. The point. Well, actually, let's look at it. I want to know, because students said that there is apparently a lot of PCBA companies in this city, and there's a lot of demand. And he wanted me to record a lecture. Okay, this is not nowhere close to C. I was wrong. But anyways, so he's saying that there's a lot of demand. So that's why I'm recording this lecture. Hopefully it helps him and some of his friends or whoever who watches this video, right? So, environment plays a big part in your process, okay? So where we were talking about method, well, actually, machine and material and methods are affected by environment. So you need to make sure you have a proper ventilation. You need to make sure there's not much dust. Your environment is clean environment, because SMT area should be very, very clean. So if there has to be some kind of dust control. And you also have to make sure your machines are not dirty. Your machines should be clean, right? So you need to have a plan for cleaning machine. You need to have a plan for cleaning machine on top of the machine, but also where the machine is operating, all that area should be clean. So you need to develop your own plan on how you're going to clean. You want to clean once a day, you want to clean once a week. All these things needs to be considered. Your humidity, you need to measure your humidity. The humidity in your room has to be a specific number, and that number changes. How do you come up with that number? Well, you talk to your machine suppliers and ask them what do they recommend. So humidity, the temperature has to be cool, because the machine produces a lot of heat. So that's why the temperature, humidity, and all these things needs to be considered. So that's the 4M1E analysis, and as a quality engineer, you need to know all these things. Then there's documentation and reporting. Well, every time you do an inspection, you should have a record. So if you do an SPI, your SPI machine should be able to generate an Excel file, and you should, have that Excel. And if you do, so let's say you're making 100 boards, okay, or maybe not 100. Let's say you're making 10,000 boards. For 10,000 boards, you better run an SPI, and you better make sure that your numbers are correct. Okay, so you better run a pilot run. So before you make 10,000 boards, you will make a pilot run, which is a couple of boards you will run through the line and see if the quality is good. And doing that pilot run is when you will improve your processes. You will make sure your SPI is right or not. And when you do the SPI, you collect that data, you run your CPK analysis, and you see if the process variation is within the limits or not, usually 1.33, right? So if your CPK is below 1.33, you're good if that's the CPK you're using. So these are the things you need to do. Then AOI, again, you need to generate the AOI report as well. Bottom line is, anytime you measure something, you should keep the data on that measurement, and that is what documentation and reporting is all about. Reporting also includes thermal profiling. Reporting also includes PM, your preventive maintenance, and your calibration records. Your training records are very important, especially for ISO procedure. For ISO procedure, ISO 9001, that the student, that the ChatGPT spit out, 9001, you need to have all the records on your preventive maintenance, that's PM, calibration, training, and all these things is very important. And then there's collaboration about what, I don't know, whatever. So these are the responsibilities of a surface mount IPQC, which is surface mount technology, in-process quality control engineering, or whatever you want to call it. So when I was Googling, I came across a whole bunch of websites on, they actually explain a little bit on what IPQC is, and these are a bunch of Chinese companies, but they seem to give a pretty decent idea, and I wrote it down here. Here are the links. I will share this. I will upload this. I'm putting this on my YouTube channel, this video, and I'll upload this on my YouTube channel. Oh, I should add X-ray, right? X-ray inspection. What did I miss? I don't know. We talked about a lot of things, and hopefully some of these things make sense to you, and some of these things are helpful to you. But as I said, you have to take, so let me close these. You have to take the courses at SMTA. You sign up, you take those courses will teach you a lot. And that's how you go about learning more. Whatever I shared in this video is based on my knowledge. Some of the stuff, I'm sure there's a lot of stuff out there, and there's a lot of stuff and a lot of updated knowledge. Today is 8 July 2025. I don't know when you're going to watch this video. When you're watching this video, it could be 2030. So it all depends on the point in time you're watching this video. If you have any specific questions, please feel free to ask me. And I know I can answer a very specific question. If you ask me a specific question and say, I want to answer to this question, I can get you that answer. If you just ask me a general question, then it's kind of hard, because the question is all over the place, then the answer is all over the place as well. So I don't know where to stop in this video. I don't know if the student really wanted what I just talked about. I'm going to ask him. Hopefully this is good enough for him. But if you have a specific question, please ask those specific questions, those targeted questions, so that I can give you those targeted answers. I hope you like this video, and please feel free to ask any questions. Enjoy.